Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 9 video on the chapter of time and work where I will solve the test paper 13, which are uh, multiple choice questions based on the entire chapter of time and work. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel and if you are visiting my channel for the first time, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. If you have not watched the previous part 1 to part 8 videos where I have thoroughly covered the concept of time and work following the textbook of author RS Aggarwal and solved the exercise problems of 13A and 13B, I strongly suggest that you watch those videos as well. So let's get started in solving the test paper 13 on the chapter of time and work. Okay, so I have written down all the questions of the test paper 13. Uh, the first few problems are subjective problems. That is, there is no choice. We have to find the answer. We have to solve it, and no choices are given. And the remaining problems are section A, all the questions are subjective. Section B, the questions are MCQ. Four choices are given where one choice will be correct. And section C, there are few fill in the blanks problem. Okay. Now, as I always say that after solving a set of problems, always, this is very important, always recall and revise the concepts and formulas that were used in solving the problems. This will provide a regular revision of the chapter concepts at the end of after solving a set of problems. Now it could be a set of it could be exercise problems from the textbook, or you are giving some mock test, or you are solving problems from some reference book. Always revise and recall the formulas and concepts that were used, and keep notes of those formulas and concepts. Okay. The first problem says A can do a piece of work in 10 days while B alone can do it in 15 days. In how many days can both finish the same work? So this is a pretty straightforward question. We have to find the work done by A and B individually in 1 hour, in 1 day. So work done by A work done by A in 1 day means work done by A alone in 1 day is equal to 1 by 10, since this is the applying the first general rule that if A can do a piece of work in 10 days, then we can say that in 1 day the amount of work done by A is 1 by 10. Similarly, we can say work done by B in 1 day is equal to 1 by 15. Now, the real meaning of the work done by A in 1 day is equal to 1 by 10. This actually means that A can complete 1 by 10th part of the whole work in 1 day. Similarly, B can complete 1 by 15th part of the whole work in 1 day. Okay. Now we find what is the work done by A plus B in 1 day. That is, A plus B means A and B are working together. Work done by A plus B in 1 day will be the sum of the work done by A and B in 1 day, that is 1 by 10 plus 1 by 15. This is equal to 3 plus 2 by 30, which is equal to 1 by 6. So if you know that the work done in 1 day is 1 by 6, we can say that the whole work will be done in 6 days. This is based on the second general rule of time and work. So this implies time taken time taken by A plus B to complete the work. To complete the work means to complete the whole work will be equal to 6 days. Because the second rule of time and work says that if in one day the amount of work done is 1 by n, then the whole work will be done in n days. So the answer is 6 days. In 6 days, A and B to working together will complete the whole work. Okay. Problem number 2. A and B can do a piece of work in 15 days, B and C in 12 days, C and A in 20 days. How many days will be taken by A, B and C working together to finish the work? This is also a very standard question. So we are given that A and B when working together completes the work in 15 days. Similarly, B and C when working together complete the work in 12 days, and C and A when working together completes the work in 20 days. So in how many days when A, B and C are working together, all of them are working together, how much time they will take to complete the work. So for this we need to first find the amount of work done by all of them in one day. Okay. Uh, so let's assume something. Let work done uh, let a work done by let work done by A in one day equals to X. We are assuming also let work done by B in one day be equal to Y, and work done by C in one day be equal to so we have assumed three things, that is work done by A in one day is X, work done by B in one day is Y, and work done by C in one day is Z. Now this implies that it is given that A and B can do a piece of work in 15 days, which means that in one day A and B, the amount of work done in one day by A plus B will be 1 by 15. So we can say that X plus Y is equal to 1 by 15. As per our assumption, work done by A plus B in one day will be X plus Y. And also it is given that A and B can do a piece of work in 15 days, which means that if the work done in one day by A plus B is 1 by 15. So we can say X plus Y is equal to 1 by 15. Similarly, we can say that y plus z will be equal to 1 by 12, and x plus z will be equal to 1 by 20. Y plus z will be equal to 1 by 12 because y plus z, as per our assumption, is the work done by B plus C in one day, and it is also given B and C can complete the work in 12 days, which means that in one day P and C, the amount of work done in one day by both B and C is 1 by 12. So this way we got these three results or equation. Now if we add this up, now my solution steps my solution is not a complete solution. I am just trying to, these will help you to understand the problem and to understand the problem and how to approach. I am not writing the solution in details as it is given in the textbook, so please be aware of this. I'm just trying to help you to understand the problem and how to approach and solve it using the concepts of the chapter. So adding 1, 2 and 3, we get, when we add a few equations like this, we add up all the LHS, we add up all the RHS, and we equate them. So we have x plus y plus y plus z. The left hand side will be x plus y plus z plus x plus z, and the right hand side will be 1 by 15 plus 1 by 12 plus 1 by 20. Now the LHS, if you observe, is x and y and z are each occurring 2 times. So we have twice of x plus y plus z will be equal to, this is equal to, the LCM will be 60, and this is 4 plus 5 plus 3. This is equal to 12 by 60, which is equal to 1 by 5. So 2 times x plus y plus z is equal to 1 by 5. So this implies x plus y plus z is equal to 1 by 5 multiplied by 2, which is 1 by 10. Now what is x plus y plus z? X plus y plus z is the work done by A plus B plus C in one day. That is, when all of them are working together, the work done in one day by all of them is 1 by 10. So this implies, applying the second rule of time and work, we can say that they will complete the work in 10 days. They will complete the work in 10 days. Since in one day, A, B and C, the amount of work done in one day by A, B and C is 1 by 10. So this, from here we can say that the total work done, the total work will be completed in 10 days. Now as I am solving, I will quickly check whether my answers are coming correct or not. The first one was 6 days, it is correct, and the second problem is 10 days. Okay, it is also correct. Okay, let's do question number 3. Tap A can fill a cistern in 8 hours and tap B can empty it in 12 hours. How long will it take to fill the cistern if both of them are open together? Okay, so we know that tap A is an inlet and tap B is an outlet. So work done by A, since the time is given in hours, work done by A in 1 hour will be equal to 1 by 8. Similarly, work done by B in 1 hour will be negative of minus 1 by 12, because tap B is an outlet which empties a tank. So when an outlet always does negative work, and an inlet always does positive work. So that is, when a tank is being emptied, negative work is done, and when a tank is being filled up, then a positive work is done. So here tap A is an inlet, so it is doing positive work, which is 1 by 8 in 1 hour, and tap B is an outlet, and so it is doing a negative work of minus 1 by 12 in 1 hour. Basically, it means that in 1 hour, 1/8 part of the tank is being filled by A, and in 1 hour, 1 by 12 part of the tank is being emptied by tap B. Okay, so now we can say work done by A plus B in 1 hour will be the sum of the work done by the tap A and B in 1 hour, that is 1 by 8 minus 1 by 12. This is equal to 3 minus 12 by 24, which is equal to 1 by 24. So we see that when both the tap A and B are working, that is both the taps A and B are opened in 1 hour, the amount of work done by them is 1 by 24, which is positive. So this means that in 1 hour, when both the taps A and B are opened, 1 by 24 part of the tank is being filled up. So the question is asking, how long will it take to fill the cistern if both of them are open together? So we can say that time taken by A plus B. A plus B means both the tabs A and B are working together, or both the tabs are opened. So time taken by A plus B to fill uh, the empty cistern, will be equal to 24 hours. If you know that the work done in 1 hour is 1 by n, that is work done by one or more pipes in 1 hour is 1 by n, and n is positive, which means that the tank is being filled up, then we can say that the whole tank will be filled up in n hours. So the answer is 24 hours. I will quickly check the answer. Question number 3 is 24 hours. Okay. Question number 4. Two men or three women can do a piece of work in 16 days. In how many days can 4 men and 6 women do the same work? Okay. So we are given in the first line two information are given, that is 2 men can do a piece of work in 16 days, and it is also given that 3 women can do a piece of work in 16 days. Now finally we have to find how much time it will take by 4 men and 6 women to do the work. Now for this we have to first find what is the amount of work done in 1 day by 4 men and 6 women, and to find that we have to first find what is the work done in 1 day by 4 men and 6 women. That is, we know we know that 2 men can do a piece of work in 60 days. So we know that 2 men does the work in 16 days. Now remember, when the work is fixed, the number of men and the number of days are inversely proportional to each other, which means that their product is a constant. So what will be, so one man, in how many days one man will do the job? So one man does the work in, it will be 2 into 16, that is 32 days. 32 days. Okay. So this is a very important concept, that whenever you are given that 2 men or any number of men does the work in 16 days, and you have to find what is the how much time it takes by one man to do the work, then remember that the number of men and the number of days are inversely proportional to each other. That is, their product will be constant. So 2 into so we know that 2 men does the work in 16 days, and we are trying to find in how many days one man will do the work. So if that number of days is y, then we must have 1 into y should be equal to 2 into 16. From here we get the value of y as 32 days. Similarly, we have now similarly we can say that one woman does the work in 3 into 16, that is 48 days. Since we know that 3 women does the work in 16 days, then we must have one woman will do the work in 3 into 16, that is 48 days. So we have this. Okay. Now we can say, we know that one man can do the work in 32 days. So we can say work done by one man in a 1 day. Okay, so so work done by one man in 1 day will be equal to 1 by 32. Since we know that one man does the work in 32 days, we can say that the work done by a man in 1 day is 1 by 32. Similarly, work done by one woman in 1 day will be equal to 1 by 48. Now, from the fact we need to find what is the work done in one day by 4 men. Now, if we know one man is doing in one day can do a work of 1 by 32, we can say that work done by 4 men in one day will be equal to 1 by 32 multiplied by 4. This is also an important concept. If you know that the amount of work done in one day by one man is let's say x, then the amount of work done in one day by p man will be x into p. This is based on unitary method. So this is equal to 1 by 8. Similarly, we will get from the fact that one woman, the amount of work done by one woman in one day is 1 by 48. We can say that work done by 6 women in one day will be equal to 1 by 48 multiplied by 6, which is 1 by 8, So we get the amount of work done by 4 men in one day is 1 by 8, and the amount of work done by 6 women in one day is 1 by 8. So this implies work done by 4 men plus 6 women in one day will be equal to 1 by 8 plus 1 by 8, which is equal to 1 by 4. So in one day, the amount of work done by 4 men and 6 women is equal to 1 by 4. This implies that time taken, we can say, applying the second rule of time and work, time taken by 4 men plus 6 women to complete the work, will be equal to 4 days. So 4 days is the answer. Let me check the answer. Question number 4 is 4 days. Okay. Let's do question number 5. A pipe can fill a cistern in 9 hours due to a leak in its bottom. The cistern fills up in 10 hours. Okay. If the cistern is full, in how much time will it be emptied by the leak? So there is a leak at the bottom of the cistern, which will act as a outlet. So leak means water is coming out of the leak, which essentially is the functionality of an outlet. So the leak will empty. So the leak per hour will empty some part of the tank. Now it is given that a pipe can fill the pipe. The pipe is an inlet. It is filling the cistern. So in 9 hours it fills the the whole cistern. So we can say let the pipe be denoted as P, and let the leak be denoted as the letter L. So P is the pipe and L is the leak, and P will do positive work and L will do negative work. So now we can say that work done by P in 1 hour will be equal to 1 by 9, since it is given the pipe can fill the cistern in 9 hours. We can say that the work done by pipe in 1 hour is 1 by 9. It is positive since the pipe is an inlet. Now we do not know, we have to find how much time the leak will empty the whole cistern, empty the full cistern. So we assume that let the leak which is L empties the cistern, empties the filled cistern in X hours, empties the filled cistern in X hours. So now we can say that work done by L in 1 hour will be equal to minus of 1 by X. Since why minus? Because a leak is an will act as an outlet, and an outlet always does negative work. Okay, so we have this. So now we can say that the work done by P plus L, that is the pipe along with the leak at the bottom of the cistern in 1 hour will be equal to 1 by 9 minus 1 by X. If we simplify this is X minus 9 divided by 9X. Now, if we express this X by 9 divided by 9 by X in the form of 1 by N, this will be 1 by 9X divided by X minus 9. So from this fact that in 1 hour the work done by P plus L is 1 by 9X by X minus 9, we can say time taken by P plus L, that is the pipe along with the leak at the bottom of the cistern, to fill the tank, to fill the cistern, that is to completely fill the cistern, will be equal to as per the second rule of the functionality, the second as per the rule of an inlet, that is if in 1 hour the work done by an inlet is 1 by N and definitely N is positive, then we can say that the whole cistern or the tank will be filled in hours. Applying that concept, we can say that the time taken by P plus L to fill the cistern will be 9X by X minus 9. Now, in the problem, it is given that due to a leak in its bottom, the cistern fills up in 10 hours. The cistern fills up in 10 hours means that the pipe along with the leak, when they are working along with the leak, is filling up the full cistern, that is filling up the full cistern which is initially empty in 10 hours. So we can say that now 9X by X minus 9 is equal to 10. So this is the linear equation in X. We have to solve it by doing cross multiplication. This implies 9X is equal to 10 multiplied by X minus 9. This implies 9X is equal to 10X minus 90, and this implies X is equal to 90. So we have assumed what was X. X was the hours, the time in which the leak will empty the filled cistern. So the answer is 90 hours. 90 hours should be the answer. Let me check the answer. Question number 5 is 90 hours. Okay, let's do. So that was the end of section A, which were all the questions were subjective. Now the section B, the questions are MCQ. Okay, question number 6. The rates of working of two pipe taps A and B are in the ratio 2:3. The ratio of the time taken by A and B respectively to fill a given capacity is. Okay, so it is asking, so both the taps are will fill our inlets. Since it is asking the ratio of the time taken by A to fill a particular capacity and the ratio between the time taken by A to fill a capacity, to fill a given capacity, you can consider it as a tank. So it is asking basically the ratio of the time taken by A to fill the tank and the time taken by B to fill a empty tank, where it is given that the ratio of the the ratio of the rates of working of taps A and B are given. Now, what is the rates of working of the taps? So, of working rate of working of a tap is equal to work done by the tap in 1 hour. Now, this work done could be positive or this could be negative depending on what type of tap it is. If it is an inlet, it will be positive, and if it's an outlet, it will be negative. Now, since the ratio, as we can see, the ratio is 2 is to 3, so definitely, and also it is asking the ratio of the time taken by A and B respectively to fill the given capacity. So, it indirectly is saying that the taps A and B are inlets. Okay. So, we know that the rates of working of a tap is work done by the tap in 1 hour. Okay. So, we will assume the rate of the taps A and B. So, let the rates of working based on the given ratio, we are assuming that let the rates of working of tap A and B are 2x and 3x respectively. You must be familiar in solving problems on ratio and proportion that whenever we are given a ratio of two quantities and and we are asked to find those quantities, usually we assume those two quantities depending on the parts of the ratio. So, for example, in this problem, we are assuming the rates, since the ratio is the ratio of rates of working of tap A and B. We are assuming that the rate of working of tap A to be 2x and the rate of working of tap B to be 3x. So, when we are assuming this, we can say that work done by A in 1 hour, which is basically the definition of rate of working. So, work done by A in 1 hour is equal to 2x, and work done by B in 1 hour is equal to 3x. So, this implies work done by A plus B, that is when both the taps are open, or in both the taps A and B are working together, the work done in 1 hour will be 2x plus 3x, which is equal to 5x. Okay. So, oh, sorry. We know we do not need to find the work done by A plus B. I was thinking that we have to find the time taken by both of them to fill the tank. Sorry. So we have to find the ratio of the time taken by A and B individually to fill a given capacity, that is to fill a tank. So we have to find what is the time taken by A to fill a tank, and we have to find the time taken by B to fill a tank. We know that work done by A in 1 hour is 2x. So we can say that time taken by A to fill the tank. Now, usually the work done in per unit time by a tap is a fraction. Now, the fraction could be also 1. If it is 1, it means that it is doing the whole work. So, it is better if we express 2x as a fraction in the form of 1 by n. So, 2x can be written as 1 by 2x, and 3x can be written as 1 by 3x. So, now we can say that if we know that the work done by A in 1 hour is 1 by 1 by 2x, we can say the time taken by A to fill the tank will be 1 by 2x. Similarly, we can say time taken by B to fill the tank will be 1 by 3x. So now we have to find the ratio of 1 by 2x and 1 by 3x. The question is asking the ratio of time taken by A and B respectively to fill a given capacity. Now given capacity you can consider it as a tank. So we have found that the time taken by A to fill the tank is 1 by 2x and the time taken by B to fill the tank is 1 by 3x. So this implies that ratio required ratio mm, is equal to 1 by 2x is to 1 by 3x. This is equal to uh, mm, you can cancel out x from both the sides. Now basically this is 1 by 2x divided by 1 by 3x. So this is x will cancel out, this will be 3 by 2, which this is a fraction and the fraction in the ratio form will be 3 is to 2. So the correct choice is choice B. So the ratio of the time taken by A to complete the ratio between the time taken by A to completely fill the tank and the time taken by B to completely fill the tank is 3 is to 2. So question number 6, choice is B. Okay, let's do question number 7. A can finish a piece of work in 12 hours while B can finish it in 15 hours. Okay, how long will both take to finish it working together? Okay, so work done by A in 1 hour is equal to 1 by 12. Similarly, work done by B in 1 hour will be equal to 1 by 15. Uh, 1 by 15. Since the unit of time is in hours, so we need to consider work done by A in 1 hour, not day in 1 hour, because the unit of time is given as hours. So we have work done by A in 1 hour is 1 by 12, work done by B in 1 hour is 1 by 15. So this implies work done by A plus B, that is when both A and B are working together in 1 hour, will be equal to 1 by 12 plus 1 by 15. This is equal to the LCM will be 60, 5 plus 4, that is 9 by 60. 9 by 60 is equal to 3 by 20. Once again friend, someone is at the door. I will come back in few minutes. আমার তো কথা নেই মাসি। Okay, friends, I'm back. Uh, okay, so work done by A plus B in 1 hour is 3 by 20. It is asking how long will both take to finish it. So this implies we can say that time taken by A plus B to complete the work will be equal to, now in 1 hour the work done by A plus B is 3 by 20. If we express 3 by 20 in the form of 1 by n, it will be 1 by 20 by 3. Now if you know from the second rule of time and work, if you know the work done in a unit time is 1 by n, then we can say that the whole work will be done in n units of time. So we can say that we are having work done by A plus B in 1 hour is 1 by 20 by 3. So we can say the whole work will be done by A plus B in 20 by 3 hours. 20 by 3 hours. Now 20 by 3 hours is 6, and 2 by 3 hours, which is equal to 6 hours. 2 by 3 hours means 2 by 3 multiplied by 60 minutes, which is 40 minutes. So 6 hours 40 minutes should be the answer. Okay, so the choices was given as in the mixed fraction only. Okay, so the correct choice should be choice B. Question number 7, choice is B. Okay. Question number 8. A can do a piece of work in 14 days and B is 40% more efficient than A. In how many days can B finish it? Okay. So we are given that A can do a piece of work in 14 days, and indirectly it is given that B is 40% more efficient than A. Now what is, it is very critical and important to understand what it means by the fact that B is 40% more efficient than A. Now what is the meaning of efficient? Efficiency you can consider regarding in the context of men and work. Efficiency of a person is equal to work done. It is similar to rate of working of a tap or pipe. So work done by the person in, you can say, 1 day. Since men and work are always the unit of time in men and work and time are always given in days. So we can say, you can think that efficiency of a person is the work done by the person in 1 day. Okay. Now, so it is given that B is B. So we can say that it is given that B is 40% more efficient than A. Okay. So we can say work done by B in 1 day is 40% more than work done by A in 1 day. So basically the efficiency of B is 40% more than efficiency of A. Now what is efficiency of A? It is work done by A in 1 day. And what is efficiency of B? It is work done by B in 1 day. So we can say that work done by B in 1 day is 40% more than work done by B in 1 day is 40% more than work done by A in 1 day. Okay. Uh, Now what is work done by A in 1 day? Work done by A in 1 day is equal to, it is given that A can do a piece of work in 14 days. So work done by A in 1 day will be 1 by 14. 1 by 14. 1 by 14. So this implies work done by B in 1 day will be equal to 40% more than 1 by 14, because 1 by 14 is the efficiency of A. So the work done by B in 1 day, which is basically the efficiency of B, will be 40% more than 1 by 14. Now 40% more than 1 by 14 means 100, 40% more. This is a concept of percentage. 40% more of any quantity means 100 plus 40 divided by 100 multiplied by that quantity. In this case, it is 1 by 14. So this is equal to 140 divided by 100 multiplied by 1 by 14. This is equal to 1 by 10. After simplification, this comes out to be 1 by 10. Okay, so work done by B in 1 day is 1 by 10. So this implies B will complete the work in 10 days. From the second rule of time and work, we know that if work done in 1 day is 1 by n, then the whole work will be done in n days. So we have work done by B in 1 day is 1 by 10. So the whole work will be completed by B in 10 days. 10 days. So 10 days should be the answer, and the correct choice is choice A. Let's see the answer. Question number 8. It is A. Okay. Question number 9. A pump can fill a cistern in 2 hours. Due to a leak in the tank, it takes 2 and 1/3 hours to fill it. The leak can empty the full tank in. We have already solved this problem previously. I mean, from the section A. It was a subjective question. Okay. So the leak will act as an outlet, and the pump will act as an inlet. So let the pump be denoted by the letter P, and let the leak be denoted by the letter L. Now, eventually we have to find how much time it will take by the leak, that is by L, to empty a full tank. For that, we need to find what is the work done by L in 1 hour. Let's assume it is asking what is the total time taken by the leak to empty the full tank. So let's assume that let L can empty the full tank in X hours. That is, in X hours, we are assuming that in X hours, if the tank is full, it will take L in X hours, the leak L can empty the full tank. So this implies basically work done by L in 1 hour will be equal to minus 1 by X, because leak is acting as an outlet, and we know that an outlet always does negative work. Whenever water is being emptied from a tank, a negative work is done. So we have work done by L in 1 hour is minus 1 by X. Now it is given that the pump can fill a cistern in 2 hours. That is, without the leak, if the leak was not there in the tank, the pump could fill the cistern in 2 hours. So we can say that work done by P in 1 hour is equal to 1 by 2. Now the fact that due to a leak in the tank, it takes 2 and 1 by 3 hours to fill it, this means that when the pump P and the leak are working together, it is taking 2 and 1 by 3 hours to fill the empty tank. So we can say, uh, okay. Now from this we can say that work done by P plus L, that is when both the pump along with the leak are working, work done by P plus L in 1 hour will be equal to half minus 1 by x. This is equal to x minus 2 divided by 2x. This you can write in the form of, you can express as in the form of 1 by n, then it will be 1 by 2x by x minus 2. Okay, so we have, based on the assumption that the leak can empty the full tank in X hours, we are having that work done by the pump and the leak in 1 hour is 1 by 2x by x minus 2. So this, from this we can say time taken by P plus L to fill the empty tank will be equal to 2x divided by x minus 2. We know that this is from the second rule of this is from the rule of an inlet. That is, if work done by an inlet in 1 hour is 1 by n, then we can say that the whole tank will be filled in n hours. So in this case we are having work done by P plus L in 1 hour is 1 by 2x by x minus 2. So we can say that the whole tank will be filled by P plus L, that is when both the pump, that is P, and the leak are working together in 2x by x minus 2 hours, which is equal to 2 and 1 by 3 hours, which is given in the problem. So we can say that 2x by x minus 2 is equal to 2 and 1 third, with this is equal to 7 by 3. So we have a linear equation in x, we have to solve it. By cross multiplication we have 3 into 2x is equal to 7 into x minus 2. So this implies 6x is equal to 7x minus 14. This implies x is equal to 14. So the leak will empty the full tank alone in 14 hours. So the correct choice is B. B is the correct choice. Let me check the answer. Question number 9, B is the correct choice. Question number 10. A works twice as fast as B. If both of them can together finish a piece of work in 12 hours, then B alone can do it in. Okay, so A works twice as fast as B, which means that A will take half the time. If the time taken by B to complete a work is x, then A will take x by 2 times to complete the work. Okay, so let's assume let B can complete the work in x hours. Since the unit of time in this problem is given in hours, we have to consider that let B can complete the work in x hours. Now this implies, from the fact that A works twice as fast as B, we can say A can complete the work in x by 2 hours. Okay, now we have to first find the work done by A and B in 1 hour. So we can say that work done by B in 1 hour will be equal to 1 by x, 1 by x, and work done by A in 1 hour will be equal to 1 by x by 2, which is equal to 2 by x. So this implies work done by a plus b, that is when both a and b are working together. Work done by a plus b in 1 hour will be equal to 1 by x plus 2 by x, which is equal to 3 by x. If we express this in the form of 1 by n, this will be 1 by x by 3. So from the fact that work done by a plus b in 1 hour is 1 by x by 3, we can say that time taken by a plus b to complete the work means to complete the whole work will be equal to x by 3. Now it is already given in the problem that if both of them can together finish a piece of work in 12 hours. So this means that in this will be x by 3 hours. So we can say x by 3 is equal to 12. So this implies x is equal to 12 multiplied by 3, 36 hours. So 36 hours should be the answer. That is, B alone can complete the work in 36 hours. So the correct choice should be choice C. Let me check the answer. Question number 10 is C. Okay. Now section C, question number 11, there are few fill in the blanks problem. The first one says a tap can fill a tank in 6 hours. The part of the tank filled in 1 hour is definitely 1 by 6. This is a straightforward question based on the first principle, that is, if an amount, if a work, that work could be a work done by a piece of work done by some person, or it can be filling a tank by an inlet, or even it could be emptying a filled tank by an outlet. So if we know that if a whole work is done in some n units of time, then the work done per unit time is 1 by n. So the answer, the part of the tank filled in 1 hour will be 1 by 6. Okay. 2 is A and B working together can finish a piece of work in 6 hours, while A can alone do it in 9 hours. B alone can do it in how many hours? Okay. A alone can do it in 9 hours. So let B alone completes the work in X hours. So this implies we can say, I'm skipping some steps. So this implies we can say work done by A plus B in 1 hour will be, we know that the work done by A in 1 hour will be 1 by 9, and we have assumed that B alone completes the work in X hours, which means that the work done by B in 1 hour will be 1 by X. So the work done by A plus B, that is when both A and B are working together in 1 hour, will be 1 by 9 plus 1 by X. This is X plus 9 divided by 9x. If you write it in the form of 1 by n, this will be 1 by 9x divided by x plus 9. So this, from this fact we can say total work will be completed by A plus B in 9x by x plus 9 hours. And it is given that in the problem it is given that A and B working together can finish a piece of work in 6 hours. So we can say that 9x divided by x plus 9 is equal to 6. So we have to solve this equation, linear equation in x. Doing cross multiplication, we get 9x is equal to 6 times x plus 9. This implies 9x is equal to 6x plus 54. This implies 3x is equal to 54, and this implies x is equal to 54 divided by 3, which is 18. So B alone can complete the work in 18 hours. 18 hours. In 18 hours. Okay. Part 3. A can do a work in 16 hours and B alone can do it in 24 hours. If A, B and C working together can finish the work in 8 hours, then C alone can finish it in how many hours? Okay. So let C alone can finish the work in X hours. So this implies a work done by A plus B plus C in 1 hour will be, we know that A can do a work in 16 hours, which means that work done by A in 1 hour is 1 by 16. So 1 by 16 plus the work done by B in 1 hour will be 1 by 24, and the work done by C in 1 hour will be 1 by X. So we have the work done by A plus B plus C, that is when A plus B plus C means that when all of them are working together. So work done by A plus B plus C in 1 hour is 1 by 16 plus 1 by 24 plus 1 by X. Now 1 by 16 plus 1 by 24, if we simplify this, we have 3 plus 2 by 48 plus 1 by X. This is equal to 5 by 48 plus 1 by X. Okay. Now if we express this 5 by 48, if we simplify 5 by 48 plus 1 by X, it is 5x plus 48 divided by 48x, and if we express this in the form of 1 by n, it becomes 1 by 48x divided by 5x plus 48. So if you know that in 1 hour the work done by A plus B plus C is 1 by 40x by 5x plus 48, it means that this means that total work is completed by A plus B plus C in 40x by 5x plus 48 hours. So now we can say it is given in the problem that if A, B and C working together can finish the work in 8 hours. So we can say now that 48x divided by 5x plus 48 should be equal to 8. Okay, so this is a linear equation in x and we should solve x. Now before solving we can cancel, that is divide both the sides by 8, and we get 6x by 5x plus 48 is equal to 1, dividing this equation both sides by 8. So now if we do cross multiplication, we get 6x is equal to 5x plus 48. So this implies x is equal to 48 hours. So the answer is 48 hours. That is, C alone can finish the work in 48 hours. 48. Okay, the last one. If A's 1 day's work is 3 by 20, then A can finish the whole work in how many days? We know that we know that So it is given that work done by A in 1 day is equal to 3 by 20. Now it is always preferable that any work done in a unit time, you always express it in the form of 1 by n. So this is 3 by 20 in the form of, when expressed in the form of 1 by n, will be 1 by 20 by 3. Now we can say from the rule that if in 1 day the work done is 1 by n, we know that the total work will be done in n days. So we can say that from the fact that work done by A in 1 day is 1 by 20 by 3. So this implies A can complete the work, that is the whole work, in 20 by 3 days, which is equal to not equal to, so 20 by 3 days. This should be the answer. Now 20 by 3 days is equal to 6 and 2 by 3 days. So it should be 6 and 2 by 3. So let me now quickly check all the answers of the fill in the blanks. Question number 11, part 1 is 1 by 6. Okay, this is correct. Part 2 is 18 hours. This is correct. Part 3 is 48 hours. This is correct. And part 4 is 6 and 2 by 3 hours. This is also correct. Okay, so this brings to an end in solving the test paper 13. The questions all the questions were pretty straightforward. 1 and 2 questions were a little conceptual, like the conceptual problem was that A works twice as fast as B. This concept was to need to be understood, and another one was the leak, a leak in a tank or leak in a pump. Question number 9 was a little conceptual, and also question number 8 was conceptual regarding the fact that B is 40% more efficient than A. So efficiency in men and work, the efficiency is always means the work done per day or per day. Okay. So I hope this video was beneficial. Solving these problems will give you a better insight of how to apply the concept of time and work to solve the most variant of questions. If this video was beneficial, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So this was only the last exercise or test exercise that was left to be completed on the chapter of time and work. Now I will start preparing and solving little harder problems on this chapter of time and work, and where in the other playlist, that is Maths 8 Hot. So please keep an eye on the other playlist, that is Maths 8 Hot, where I will solve relatively harder problems on time and work. So I will end the video here. Thanks for watching, and until the next video, take care and bye.